In mathematics, a piecewise linear function is a function composed of straight-line sections. It is a piecewise-defined function whose pieces are affine functions. If the function is continuous, the graph will be a polygonal curve. Examples: the function defined by is piecewise linear with 4 pieces. Since the graph of a linear function is a line, the graph of a piecewise linear function consists of line segments and rays. Other examples of piecewise linear functions include the absolute value function, the square wave, the sawtooth function, and the floor function. Fitting to a curve. An approximation to a known curve can be found by sampling the curve and interpolating linearly between the points. An algorithm for computing the most significant points subject to a given error tolerance has been published. Fitting to data. If partitions are already known, linear regression can be performed independently on these partitions. However, continuity is not preserved in that case. A stable algorithm with this case has been derived. If partitions are not known, the residual sum of squares can be used to choose optimal separation points. A variant of decision tree learning called model trees learns piecewise linear functions. Notation. The notion of a piecewise linear function makes sense in several different contexts. Piecewise linear functions may be defined on n-dimensional Euclidean space, or more generally any vector space or affine space, as well as on piecewise linear manifolds, simplicial complexes, and so forth. In each case, the function may be real-valued, or it may take values from a vector space, and affine space, a piecewise linear manifold, or a simplicial complex. In dimensions higher than 1, it is common to require the domain of each piece to be a polygon or polytope. This guarantees that the graph of the function will be composed of polygonal or polytopal pieces. Important subclasses of piecewise linear functions include the continuous piecewise linear functions and the convex piecewise linear functions. In general, for every n-dimensional continuous piecewise linear function, there is a such that if is convex as well as continuous, then there is a such that. Splines generalize piecewise linear functions to higher-order polynomials, which are in turn contained in the category of piecewise differentiable functions, PDIFF.